So students, now we are going to discuss about the next topic. The next topic is a very simple topic. You would have already seen that many times. Have you ever tried to throw a bullet out of a gun? Play with a toy gun, I mean to say, I'm not talking about a realistic gun. So what you feel, as soon as the bullet oozes out of the gun, you face a recoil in the backward direction. Why is that so? The reason being, there is a conservation of momentum. So we'll learn more about this in two realistic examples, that is the motion of a horse and a cart and the recoiling of the gun in this particular topic, that is the motion of the cart. So let us discuss some activities before we move on to the motion of the car and try to understand why the motion of the car, what all exactly is required for the car to be moving or for the car to be moving. So let's understand it using some activities. So what are the activities on the momentum conservation? First one, let's say if you have a straw, and to that straw if you fix up a balloon, if we allow the air to come out of the balloon from one end, it is going to make the balloon move in the forward direction. So this way, what happens, the balloon can move in the forward direction. In a similar manner, if we fill in a test tube with some water and start heating this test tube. So once we start heating this test tube, what is going to happen? The cork is going to come out. So when the cork comes out, what is going to happen? There is going to be a conservation of momentum that is going to take place. Because you did not apply any external force, the cork comes out, the test tube moves in the opposite direction, thereby making the momentum conserved in this whole system. So this is the action and this is the reaction that we have. So action is the motion of the cork and the reaction is the motion of the test tube. In a similar manner, if I say that I have a rocket that is flying off, so in this case, the hot air gases that are coming out is the action that pushes the rocket in the forward direction. So that is the reaction that you have, and the action are the movement of the hot air gases. In a similar manner, let's say there is a wolf. The wolf tries to push the ground in a backward direction and the ground pushes the wolf in the forward direction. As a result, the wolf is able to move forward. Here, the screen is small enough for the wolf to moving out, so it cannot move further outside. If we discuss about the motion of the car, so talking about the motion of the car, let's say is moving in a straight line path, then it will have a weight acting in the downward direction and there is going to be a normal reaction that is going to be acting. The normal reaction is going to be R and the weight is going to be equals to mg. Here, assuming there are no other forces that are acting on it. Similarly, if the car is moving in an inclined plane, let's say like this, so there is going to be a normal reaction acting like this, which is going to be perpendicular to the inclined surface, and there is going to be a weight acting in a downward direction. So these two forces are not along the same direction. That is the reason there is a resultant force because of which the car is going to move in a downward direction. Clear? Let's now take the case of a horse and a cart. So talking about a horse and a cart, what happens is that a horse pulls a cart, but since we know from Newton's third law, the cart should also be pulling the horse in the opposite direction. So both of them are going to exert forces on each other. So if both of them exert forces, then how can they move? So let's try to understand about that. So let's say this is the cart, this is the center of gravity or center of mass. At this point, there is going to be a weight acting in a downward direction and a resultant force acting in an upward direction. Further, if we say that this is the tension that with which the horse is able to pull the cart, so you have the cart versus horse tension here and a horse cart tension out here. So both these forces are going to be oppositely directed. Further, the horse pushes the ground in the backward direction, so with a force P, and the reaction is going to be R. If I suppose that R is acting at an angle theta with the horizontal, so what we can do is that we can resolve the forces such that R cos theta is going to be the force along the horizontal direction and R sin theta is going to be the component along the vertical direction. So R sin theta, since it is acting along a vertical direction, so it is going to be balancing the weight of the horse, and obviously the weight is going to be balanced across all the legs, but let's assume at this point there is some amount of weight that is being balanced, and the horizontal force R cos theta, that should be more than the frictional force for the simple reason because if it is equal, in that case the horse cannot move. It has to surpass the frictional force, only then the horse can move in a forward direction. So the cart will only move if r cos theta value is going to be more than the value of f. Hopefully it makes sense. Now, if we go further, we can understand more about this. That is, what exactly is the apparent weight and so on. That we'll cover in our next topic. Thank you. Well, students, you understood about how does a cart move in the forward direction. So when the toe of the horse pushes the ground in the backward direction, that makes the horse move in the forward direction. So this is a concept which is also based on the Newton's third law of motion, that is, every action would have an equal and opposite reaction. So if we try to draw the free body diagram for the case of the horse moving in the forward direction, you can actually find out what are the forces that are balancing the weight and what is the force that is pushing the horse in the forward direction. We'll take it further and try to understand about the apparent weight, and when an object is in motion under gravitational field, what all is the net weight acting on an object. So stay tuned to understand about that topic, apparent weight.